Okay, I'm going to be going over lines and angles and triangles. Two lines that never touch, even if you stretch them forward or stretch them back. If they never ever touch, we call those parallel. And the way I remember this, the way you should remember this, is there are two L's inside the word parallel, and those two L's are parallel. They never touch. They shouldn't. Okay, so parallel lines never touch. They never intersect. Again, even if you were to stretch them up or stretch them down, because that's important to know that, because that's how you're tested. And I'll show you in a bit. So perpendicular lines cross, they do touch, and they cross at such a perfect and create such a perfect corner. Actually, they make right angles. So if this is a right angle, this corner is a right angle. So if I go in like this, I say, wow, look at that. It's a perfect little corner. Perfect corner. Perfect corner. And perfect corner. So perpendicular lines create perfect corners, or four right angles. So we call these a right angle, also known as a 90-degree angle. And so perpendicular lines create four right angles, and that's how you know they're perpendicular. 90 degree, a right angle, 90 degree. And then the symbol that means right would be this little, it's like a little square, and that would also be your clue that there is four right angles there, and that these are perpendicular lines. Perpendicular lines form a perfect plus. Okay, that's your little clue there. And then intersecting lines will always form, and let me show you with this little corner trick, with the post-it trick, that if you go in, you're going to notice it is not a perfect match here. It's not, this is a larger angle. This is greater than 90, because I know this is 90. This corner is 90. And so here it fit just perfectly. See that? But here, when you go in, pretend it's a puzzle piece. When you go in, you notice that there is that extra space, and therefore it lets you know that it's greater. This angle is greater than 90, so we would say that's obtuse. Same thing up here. If I go in like a puzzle, I notice that the angle is actually greater than 90, therefore letting me know it's an obtuse. And then if I go this way and go in, go in, go in, I actually cover that angle. See that? My 90 degree covers, look, I go in, so this little point goes to in here, okay? So I go in, uh-oh, the entire angle gets covered, and so that's my clue that it's an acute angle. I guess I should write the whole word. Obtuse. And it also forms another acute on this side, okay? So intersecting lines will always form two obtuse angles and two acute angles. Intersecting lines. And I guess I should have started with angles. Okay, so I'm going to go back to these pictures in just a little bit. So let me go ahead and show you angles. A right angle is a perfect corner. Okay, so it's a 90-degree perfect corner, and I always like to use the post-it trick, which tells you that this corner, or any corner of a paper, is 90 degrees. Okay, so this perfect corner is 90 degrees. And you can even trace it and create a 90-degree perfect corner. And to identify it, you'll usually see this little symbol. Okay, this little tiny little square. I'm not sure if it has a name, but that's your clue that it's a right angle. And it measures 90 degrees. And then anything greater than 90 like 91, 92, 93, or anything greater than that is obtuse, is an angle that measures and it's greater than 90. So what I can do is I can make one of these lines here, and then I just make sure that the other one has to be greater, so it has to be anywhere up. Okay, so there, that's obtuse, greater than 90, so I'll just put it up here. Greater than 90 is obtuse angle. And the last one, anything smaller than this perfect corner, is acute. Acute is anything smaller. So make sure your angle has to be, it cannot go right on top of the line. It would have to go somewhere under it. Okay? So that when you go in and try to match, it'll cover it. So that's how you do the post-it trick. When you go in like a puzzle with this little point, you go in, and if the post-it covers it, boom, you know you have a acute angle because it is less than 90 degrees. So 89, 88, 87, 86, all of those degrees would be acute, all the way down. Okay, so what happens if I get an obtuse, and let me just show you with this. If I get an obtuse, if I get a right angle, right, like this, and I start opening the angle and opening the angle and opening the angle, eventually, if I open it all the way, it would equal 180 degrees. Because remember, this is, for example, 10 degrees, 30, 10, 20, 30, 40, 50, 60, 70, 80, 90. And then we would say 110, 120, 130, 140, 150, 160, 170. And once you get to 180, you're actually just going to form one straight line. So there's actually an angle called a straight angle. And that straight angle will always measure 180 degrees. Okay? And of course, so that would be like a half turn. So I would go from here, and then it would open, 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 up to here. Just pretend it's like a half turn. Okay? And so what happens if you keep going all the way under? You would eventually form, and let me just draw it on this side. If I got a 180 degree angle, and I went up, 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 and touch, that's 180. But what if you go underneath it and touch, right? Then to 180 degrees, when you add that up, it equals 360 degrees, and that would be a full turn. So anything that is a complete full turn circle would be 360 degrees. Now, that's not tested in 4th grade, so don't worry about that. But, I mean, it's good for you to know. So 180 is a half turn, and then if you keep going under, you form a 360 turn, an entire full turn, okay? Half turn, full turn. So 180 plus 180 equals 360. Okay, so this is a straight line, again, is just called straight angle. All right, and then triangles. Actually, let me go up here to these symbols, or to these pictures. So it's not going to be that easy of a question. What they will do sometimes in a test is they'll just put some random picture, and then they'll ask you, does this picture contain perpendicular lines? And your job is to think outside the box. So you're going to look at that picture, and you're going to say, well, I see this line right here. And if I stretch that line, and then I see this line here, and if I stretch that line, there is actually perpendicular lines right here. Let me grab a different color. This corner of this face has perpendicular lines right there. Now, your job is to stretch them. They are not going to stretch them for you. They just want you to think outside the box, and they want you to stretch them. And yes, there, I have perpendicular lines hiding right there. I have perpendicular lines hiding right here, another set of perpendicular lines hiding right here, and another set of perpendicular lines hiding right here. I have a straight angle there. I have, perhaps if they ask, I have one right angle right here. I have a right angle here, right angle here. I want 4, 5 right angles, 5 right angles, 6, 7. Maybe this is, let me see if it's acute. I would go in and I would say, well, it covers one of the sides. You see that? So then I would say this is acute right here. This one's acute. So these angles are acute. This is acute right here. This is acute. This is acute. You have to really think outside the box. Oh, look, here's another right angle right here, because this forms a right angle. These two right here form a right angle. There's another right angle here, another right angle here. So it's, you just don't know what they're going to ask you. So anytime you have a picture, think outside the box and identify how many angles or how many lines. Is there any parallel lines? Here, yes, there is. Let me show you. One side of the face, if I stretch it, and the other side of the face, if I stretch it, I have parallel lines. The left side of the face and the right side, they never touch. They will never touch. They're parallel. But you can also say you have another set of parallel lines because you have the top of the forehead with the bottom of the chin, so that's another pair of parallel lines. Or you even have parallel lines in here. Look, left and right, one set. Top and bottom, another set. Left and right, one set of parallel lines. Top and bottom, another pair. So again, I can go on and keep finding more, but that's just how you are tested. Or they might give you a clock and say, it's 5 o'clock. What type of angle did it form? Oh, well, did it form a right angle? No, it's greater than right, so we know it's obtuse. These are just types of questions you get in 4th grade, okay? Always think outside the box. And the last thing I need to teach is triangles. So if the two sides are the same length, we call it isosceles. If I have a shape, and I'll try my best, but if I have this length and this length, these two lines are the same length, and then I have a short one here. I would say, well, I would go measure him and maybe even mark it, and I would say, well, this little line measures and is the same size, right? Same length as, so these two are the same length, but it's very obvious that the bottom one is shorter. So he is, identify him by putting 2 marks. So 2 sides are the same here. So the way I remember isosceles triangle is 2 sides are the same here. Maybe I'll do side and side. 2 sides are the same here. Isosceles triangle will always have 2 sides the same. Then you have an equilateral will have 3 sides the same, and I'm going to try my best. They're probably not the same, but this side has to be the same length as this side, and this side has to be the same length as, all 3 have to be the same. And if you go measure to make sure, you would say, well, this is an equilateral. Sorry, I misspelled it. This is an equilateral triangle. Okay, and the last one is a scalene. A scalene will have no sides that are the same. So you'll have a very long side and a medium side and a short side. Okay, so you're going to have one that is short, really short, and then you're going to have a medium side that is the length of a medium, and then we're going to have the largest one. So you're going to say, well, none of those sides are the same length in a scalene triangle. And that's how you know it's a scalene, because it has no sides